All right, people, let's dive into the Python programming. And what we want to do over here is that we will learn about, how to do programming in Python. And what am I going to do? I'm going to create a new Python notebook over here, and I'm gonna type this over here. This is going to be the lecture one. So all the lecture one files you will be able to get in the resource folder. So it'll say lecture one, and what we want to do is basic operations in Python, right? So we will be writing basic operations in Python. All right. So this is what we are going to learn, right? And in Python we want to understand, right, how it works and how it goes. So there are a couple of things which we wanted to do in the coding. So I'm going to type in some codes over here to make sure that you understand it, and I'll keep saving this file so that that you can receive the latest file over here. So the one thing which we wanted to do is this is the cell wherein you can write any number of codes, right? So I can write some code over here, and this is practically unlimited space. But what do we want to write over here, right? So let me just show you some basic math operation. So you can do some basic math operations and these basic math operations are as good as doing certain things. Like, so I'm just gonna keep this as a heading, as a markdown option. And what basic math operations I can do, I can add some numbers to some numbers and it will give you the output. I can add multiply some numbers with some number and it will give you the output, right? I can use this number minus some number, and I click on I do shift enter and it will give me the output, right? Whatever is the output. Or even if I want to divide certain thing, I can divide it by this and execute this, and you can see the output over here. So the basic operations which can be performed in Python, which is very simple. You just need to write the code over here and it will be able to give you the output. All right, what next, right? What we can do apart from that? Apart from this, you can also assign some variables, and this is where Python is very interesting, right? So let's assign and use some variable names, right? And we will be using this functionality of Python a lot of time, right? So we will be saying let's assign and use some variables. And how do we do that? We can just simply say suppose x is equals to some number and execute this. And if we say what is x, hey Python, what is x, so it will come back and say this is the number, right? And we can reassign the values as well. Reassign the values, right? How we can reassign the values? I will say no, x is not 68,328, it's a different number altogether. Execute this and I say what is x, it says okay, now I am able to understand that there is a new number altogether. So you can see over here that we are able to get the assignments of the variable with any number, and you can typically use any variable. For example, I can say data is equals to some number, right? Or I can say my name, right? Sudhanshu is equals to some number. This will all work, right? Now a couple of things you will notice over here that when I'm writing certain letters, that it is turning into green. For example, if I'll simply type true, right, over here, you will see that it is in black color. But if I write capital T true, it is actually coming out as green. Now this green color means that these are Python reserved keywords, and I should not be using this variable as a to store the value. However, if I just simply use, if I say simply true and assign some values, the value will still be there, right? Value will still be there, but Python will not be able to store that value, right? It says cannot assign this value to true, right? So you should avoid doing this. However, if you wanted to use something, you can just simply say true value. Since this is not a Python reserved keyword, Python will be happily accepting this, right? So you can just type in this value and it will be able to show you this new number over here. Now Python also auto completes this thing, right? So if I say true underscore and I hit tab, Python will be able to auto complete this value by its own. How do you use autocomplete, right? So autocomplete works with the tab command, right? Tab, right? So you have to do tab over there, and autocomplete will be able to do that job for you. So this is how you can do the autocomplete, right? Now let me just quickly pick up one variable name. So I'll say I underscore m underscore n underscore Indian, and I can assign some values to this number as well, and it will very well be taken by Python. So if I wanted to see I underscore and I'm hitting tab, it will autocomplete itself and execute this, and you will see that this number exists over here. So now you know that how we can assign values to it. Let's create different variables. So suppose I'm saying x is equals to some number, I'm saying y is equals to some number, z is equals to some number, right, and g is equals to some number, right, and h is equals to some number, and if I execute them all, Python is able to learn all of them. Now I can say, suppose multiply is equals to x multiplied by y multiplied by z, right? And this is how, I mean, that it's that simple. And you can say what is multiply over here, and Python will be able to revert back, right, without any problem. So in Python, the code executions happens line by line. So first this line will be executed, and Python will be able to compute x multiplied by y multiplied by z, and will be able to store the results into a word called multiply, and will be able to give you, and in the next line when you are asking it to print the value, it is printing out that value for you. So Python like works sequentially over here. So this is how you can do it, right? Simply now I can just simply say a is equals to some number and b is equals to some number, and execute this, and I say c is equals to a multiplied by b, right, or a plus b, simple, right, and execute this, and I say what is c. You can see that this is a addition of these two numbers which I have defined over here. So working in Python is very, very easy, especially for data science, because the reason, because it is actually using the functional programming here, because we use a lot of times equal to symbol. Now you should also be familiarize yourself with some kind of errors. For example, if I say, hey Python, could you please tell me what is data? Right now the data value is being defined somewhere over here. So if you see, I have somewhere defined 7732 as data, until the time session of like this Python, this kernel is working, Python will be able to remember this data data format. But again, if I just simply say tell me the original data something, or I just pick up some variable name, right, data underscore where, tell me what is data underscore where, I'll get a name error over here, right, and name error will say that data is not defined. Now why it is not defined? Because Python is, you've not given value, right, so that Python can remember what is the value of data underscore where. It doesn't work like that. So here if I simply say data underscore where is actually some number, execute this, and I say what is data underscore where, right, and it will say that it is 874387, right, which is 874,387, right. So it can give you that number over here. So you can see that Python is very well very, very sorted language, and it has got no it's not giving you some like stupid errors like indentation or something. It just, I mean, it's happily taking up the value, right. So for example, I can say my where say my underscore where is equals to, and I just give a space and then pass on this value. My Python will be able to take that up. I will not say no to it, why you have given some spaces like that, or Python don't give you that kind of error, right. So if you see that this is the number which is being defined over here. So these are some salient features of Python. You will find Python in a very, very I mean, it's very, very amazingly written data and amazingly written language, and then you will not find that Python is not giving you unnecessarily errors. Now what am I going to do, people? I'm going to show you a couple of things. For example, if I've defined, right, x is equals to 100, right, and if I say y is equals to 100.1, and if I define, like, let me just define this much, right, let me just define this much, and if I say what is x, it will come back and says 100. And if I say what is y, it will come back and it says 100.1. Now if I simply say what is the type of x, it will come back and says integer, right? You can see that it is showing you the integer value over here. And if I say what is the type of 100.1, it will come back and it says it's a float. Or if I just pass on this value right over here, which means that it shows that it's a floating value, right? So the reason why it is doing the same reason, because Python is dynamically typed language, which means that you don't need to define the type of variable in Python, right? It does it automatically, it does it completely automatically. So you can see Python is a dynamically typed language and you don't need to define that, right? Suppose I am just giving you some more examples. Suppose I'm saying b1, some variable, is equals to true. The moment I type in true right, and it converts into green, and I say b2 is equals to false. Now these are Python reserved keyword, and if I say type of b1, it will come back and it says it's a boolean value. Or if I say type of b2, it will come back and it says it's a boolean value. So you can see here that Python is able to automatically recognize that it's a boolean value, and it should be considering this as boolean thing, right? What are the other things which I can do right over here? Suppose if I'm defining the complex characters, so let me just type in some complex character. Python can deal with complex numbers as well, complex numbers, right? So how does it deal with that? So I'm going to show you, right? Simply over here I can say some x is equals to 1.0 plus 2.0j, right? And people who know the complex numbers, this is how you define the complex number, okay? And if I say what is the type of x over here, and it says it's a complex number, right? So we can define, right, what kind of data we have over here, and it can let you do that job, right? And you don't need to define that it's a complex number. Python knows that it's a notation of complex number, and it picks up that value as a complex value. Now what else we can do with Python, right? I can check some expressions, right? Let's verify some expressions. How can we verify some expressions? For example, if I'm defining num1 equal to, and I just simply say num1 is equals to some number, and I say num2 is equals to some number, and that number is a negative, and I will also define num3 over here is equals to 123.456, right? And I can define num4 is equals to some very high number, right? Over here you can see that I've defined them in one go, and Python is happily accepting it. And I'm saying is num1 equal to, now here is the catch. If I say suppose if I'm saying is data equal to num1, what this command is going to do, right? It is going to num1, it is going to pick up the value of it is going to pick up the value of num1 and store that in data as variable. Okay, so if I just execute this and I say what is data over here, you will see that the value is 5665, right, over here. So you can see that this is how Python works. Now what am I going to do? I'm going to verify if num1, if I wanted to check if num1 and num2 are equal, I can say if num1 equal to num2, and what am I supposed to get as an output is a boolean value, right, whether it is true or false. So if I execute this, you will see that false option is present, right? Or if I can say if num2 is equal to negative 7667, if I execute this, it will come back and says true. Yes, this value matches. So it is actually calculating the boolean output, and it will not give you some result. It will just check the condition and give the response to you, right? I can also check if num1 if num1 is lesser than num2, I'll get a reply over here, or if num2 is greater than num1, you will get the reply over here, right? So you can see that all of these values work. I can check for some numbers. If this value is greater than this value, execute this and we'll be able to tell you that it is working or not. So now what it does, right, you can pick up an expression and it works. So for example, I can say 5 is greater than 3 is lesser than 4, right, equal to, sorry, we'll use equal to here, and I'll say 3 plus 1. Execute this and it will come back and says 4, right? So it will be able to check all these values, whatever output over here, and it will be able to give you the output of it, right? So 1 equal to is assignment operator, and double equal to is conditional checking, right? Now if I what are the different types of values you can use? Complex data you can use integer, you can use real and imaginary number. It will be able to do all of those tasks for you, right? I can also check, suppose I'm defining x is equals to 1.0, right, and I say what is the type of x. Execute this and you'll see that it is actually a float value, right? And we can verify this, right? Now look at this, how easy it will be to check that thing in the Python. So check if the variable is a float, right? And how can we do that? We can say type of x is float, right? Execute this and it will come back and says true. You want to do that again, you can say type of x is integer, type of x is integer, and if you execute this it will say false. Now we can say suppose x value is equal to 1, you can see that it is converted into integer. Now if I execute this, this will become false and this will become true, right? Let's verify this. This will become false and this will become true because it's actually an integer over here, right? We can also check some methods. So we can use the instantiate is instance method for testing the types of variables. How can we do that? We can simply check is instance. Now is instance, we will say please check x for float, right, and we'll come back and it says false, right? You can say is instance check x for integer value, right? Execute this and you will say true, right? So you can see over here that that the value can be picked up in this way, right? Now here is the catch. Can you convert the value, right? Converting the types of data, or you can say data conversion. How can we do that? We can simply do that by doing certain thing. For example, x is equals to 100, right? And if I say could you please print the type of x, right, it will come back and say it's an integer class, right? It is actually doing this. Now if I say x is equals to float of x and come back and I'll say could you please print the type of x, now it will come back and say it's a float value. So I can convert that value into a floating value as well. Now what will be the difference over here? So if I'll simply say print the value of x and also the type of x, execute this and you will see that 100.0. earlier this was only 100, right? Suppose if I just simply say over here x comma, right, so you can see that it will print that 100 is there and the class is integer. When I've converted that into float value and I say what is the type of float, you can just ignore this for a while. We can say that print x and also the type of x, and once you convert that into this, you can see that the 100 is now converted into 100.0 and float. Now we can also do one thing. For example, we have data and data value is 123.456, right? This is my floating value. I'll say please print the data and also print the type of data, right? execute this, and it will say that this is actually a floating value, and I can say data is equals to integer of data. Okay, integer of data, and I'll say print again the data and the type of data. Execute this, and you'll see here very interesting thing. It has first of all converted the value in from floating to integer, right? And it simply, I'll just write it over here, right? I'll just write it over here. It simply drops the values after decimal if needs to be converted into the converted from float to integer, right? And it just simply work like this, right? So this is how Python is able to do typecasting for you, right? So basically you can call this as this. I'm doing the typecasting of the data. Typecasting. Now this typecasting doesn't work on every part, right? Why it doesn't work? For example, if I have an number which is an integer value, and if I wanted to convert that into complex, I can do that. For example, I can say z is equals to complex of data. If I just simply say complex of data, I will be able to print the value of z, print the value of z, and print the type of z over here. And you can see that it has converted that 123.0j over here, and the class become complex, but not vice versa is possible. For example, if I just wanted to say converted is equals to integer of z, I'll get an error, right? Now the reason is that I'll be getting type error because complex data cannot be converted into integer value, right? So you'll get an error over here. So this you need to remember, that not everything is convertible. Everything has to be there are certain things which needs to be converted. Not everything is there, right? Alright, so what are the other things which Python can do? See, these are the basic ways of dealing with it. I can also show you some basic operations, like Python deals with power as well, right? So for example, we have to go for power of the variable. You can see power of a variable can be, I think W is not working properly, so we can give power to a variable. For example, if I say 2 raised to the power 2, right? And if I say 2 raised to the power 2, it will say 4. 2 raised to the power 3 is going to be 8, and 2 raised to the power say 10 is going to be 1024. So you can see here, this is this double asterisk denotes the power of a variable, right? Raised to the power, right? This is how it works. Now I hope you're getting some idea about the basic understanding of it, right? What we want to do is, in the next lecture, I'm going to talk about more in basic operations. I'll see you in the next lecture, and this sheet is attached in the resources tab. You can just go over there and check for it. I'll speak to you in the next lecture. Bye bye.